Alright, so the next topic in logarithms is solving. So we're going to solve both exponential and log equations. So how do you solve an exponential and how do you solve a logarithmic equation? Okay, so these are three possible logarithmic equations. You can either be asked to find the argument, the exponent, or the base. Typically when we solve logarithmic expressions, they're going to be like example A, but these other ones you can be asked to solve these as well. Okay, so when you're given log form, so these all have logs. If you start with log form, then you need to convert log form to exponential form. So look for the base of the exponent. So here the base is 36. Here the base is 16. And here the base is x. Then you do the little switcheroo. So what the log is equal to becomes your exponent. And then what the argument is becomes what it's equal to. So here this one's going to be 3/2, and the argument is going to go over here and be x. So the argument is 1024, and the exponent is x. So again, 3/2 here, and the argument is 27. So yes, you can use a calculator, but I'm going to review what these mean. So remember, when it's an exponent, you're going to take the root of the base, 36. So you take the bottom root, which is the square root, and you raise it to the third power. So the square root of 36 is 6. And then when we cube that, we get that x equals 6 cubed is just 216. Okay, so just reviewing what rational exponents do. So right here, if you look at your chart, we're going to see that there's no power of 16 that goes into 1024. So what we have to do is we have to rewrite these as common bases. So right here, 16 is 4 squared. We have an x there. And we want to make 1024 with the same base. So we want to make this one have a base of 4 as well. So 4 to what exponent is 1024? Looking at the chart, we get 10 to the 5th. Once you have common bases, they cancel out. Then you get 2x equals 5 divided by 2. X is just 5/2. Okay, so that's solving with common bases. And then the last one is solving with the rational exponent. So here we want to get x by itself, which means we have to get rid of this exponent. So we get rid of a rational exponent by raising both sides to the reciprocal. So we're going to raise both sides to the 2/3. To the 2/3. So this cancels. And we have x equals, then we evaluate this. So the cube root of 27 squared. So the cube root of 27 is 3. 3 squared is 9. So here x would be 9. So again, these are all solving equations, solving for x. However, normally when we solve a logarithmic equation, we're usually going to have the variables as the arguments inside the log. So that's like this one here. This one has an argument as x. This one doesn't. This has an exponent as x. This one has a base of x. So we're going to solve ones that are more like A than like B and C. So the first case, I call this case 1, which is the basic case, the easy case. I guess this is case 1 right here. but these are pretty straightforward as well. So the rule is, if you have two logarithms on both sides of the equation, if they have the same base, then you can cancel those bases out and just set the arguments equal to each other, if those arguments are positive. Okay, so we'll talk about the positive part in just a second. So right here, their logs have both base 2, so those cancel out. So here the arguments are equal, so x equals 7. But, I mean, you can have more steps than that. So like right here, for example 2, the bases are both 7, so they cancel out. So you set the arguments equal. 6x minus 16 equals x minus 1. And you solve for x. So subtract x from the 6x to get 5x here. Get all your numbers to one side. So we want to move the negative 16 over here by adding it. Oops. I already said the answer. So add 16 to the negative 1. And we get 15. Divide it by 5. X is 3. Okay, so I'm going to come back and use this space in just a second. So right here, again, same thing. Bases are both log 5. So we cancel them out. And we set 2x minus 7 equal to 3x minus 9. So we want to move our x's to one side, so I'm going to move the 2x this time to make just an x over here. And I want to move the numbers to the same side, so I'm going to add 9 and add 9. So we get x is 2. Okay, so that's the solving part. But remember, we can only have positive numbers inside the logs. So that's what this says. Check for extraneous solutions means that you got to make sure when you check and you plug them back in that you get a positive number. If you get a negative, there's no solution. Okay, so if we plug a 3 in here, we're going to have log base 7 of 6 times 3 minus 16. So here we get 6 times 3 is 18. 18 minus 16 gives us 2. So here we would get log base 7 of 2, whatever that number is. And then if I plug it into this side as well, again I get log base 7 of 2 minus 1, or sorry, 3 minus 1, and 3 minus 1 is 2 as well. So this one checks out. This one's good. But they got to be a positive number. Here, when we plug 2 into x, log base 5 of 2 times 2 minus 7. 2 times 2 is 4, and 4 minus 7 is log base 5 of negative 3. So here, even though when we plug it in on the other side, we're going to get negative 3 as well. We get the same number that they're equal to, but we can't do that. So in the calculator, log, you go control and then x to the 10, or 10 to the x. And if you try to do this, you put base 5 and you put a negative 3 here, it's going to say error, not a real solution, because you can't have negatives inside the log. So you have to be careful when you solve these case 1 type problems, because if you plug it back in and you get a negative, this is not a solution, which means this thing has no real answer, because can't have a negative. Can't be negative. When you plug it back in, the answer can be negative, that's okay, but it can't be negative when you plug it back in, or 0. Can't be 0 as well. So you just have to make sure you check. Okay, so that's case 1. Now we're going to go into the general cases of solving with only one logarithm. Alright, so what I'm going to do with these next few cases is it's kind of a mixture of exponentials and logs. I'm going to go through all of them and I'm going to do the logs first, and then I'll come back and do the exponentials. So the log equations, the logarithmic equations, are the ones that say log. So the goal of solving a logarithmic equation is to get the log and the argument part by itself. So the way we do that is we undo order of operation, so we're using SADMake here. So the first thing is to subtract or add any numbers outside the log, which would be the +7. So we're going to subtract 7 from both sides. Now this negative is not part of the log, so I'm going to rewrite it as -1 times log base 3 of 8x equals -5. But this log still isn't completely isolated. We still have that -1 in the front, so we either want to divide or multiply to get rid of it. Normally we just divide both sides by that -1. If it's a fraction, then you multiply. So here we're going to end up with log base 3 of 8x equals negative and a negative makes +5. So you might not always have an add or subtract, you might not always have a multiply or divide, but you will always have an exponent step. So we want to make the log into exponential form. So here, when we convert it to exponential form, 3 is the base, and then the other ones do the switcheroo. So the 5 is the exponent, and the argument is what it's equal to. So now it's an exponential form. That's how you solve a logarithm, is by converting it to an exponential. So here we can do 3 to the 5th. You can either use your chart or use your calculator. I mean, we're going to be using calculators for this, most of this unit, because we have a lot of log stuff. So 3 to the 5th is 243 equals 8x. And then we finish solving the grouping symbols by divided by to get x by itself. So here, just divide this by 8. So you can either write it as a fraction, x equals 243 divided by 8, but a lot of these are going to be decimals, so if you change this to a decimal, you go menu, number 2, and then number 1 is convert to a decimal, and this is 30.375. Okay, all of them, if you need to round to 3 decimal places to the nearest thousandth. This one we don't need to round because it's terminating anyways. Okay, so we'll come back and do part A with exponentials, but I want to do all the logs first. That way you can get those out of the way. Alright, so skipping to the next page. These are exponentials. So I'm going to do example 6 here because those are logs. So looking at A, remember the goal is to isolate the log and the argument by itself. Well, if we look at that, that's all that's there. So in this case, there's nothing to subtract or add outside, and there's nothing to divide or multiply by on the outside. So we go straight to the exponent, which means we want to convert log into exponentials. So how do we make this an exponential? Well, you take the base, and then you switch the other two around. So the base comes down, and the exponent and the argument switch. So 5 here, and 10x plus 624 there. figure out what that number is in the calculator. So 4 to the 5th is 1024. So 1024 equals 10x plus 624. So now we finish solving the rest. What was in the grouping symbols, what was in the parentheses, we now finish solving for x, just regular. So minus 624 gives us 400 equals 10x. And then we divide by 10. X is 40. Okay, now just like we did before, you should double check that this number in here actually does end up being positive. Usually when you only have one log, you don't have to worry about that because that's what it's going to be. It's when you have two logs on either side, when they cancel each other out, that you have to check. But you can check these if you want as well, just to make sure it's a positive. So 10 times 40 is x plus 624 would give me a positive number. And then I can actually solve it to check that it is 5. But right now we're just double checking that it's a positive. Okay, so now on the other side, this one has multi-steps. So again, locate the log and the argument. The log is the log part and the argument is the parentheses. If there's no parentheses, then it's the number after the x. So we'll see some of those in a second. Okay, so first we need to subtract or add. So we're going to subtract 8 and get 3. I go ahead and separate these by putting a little times sign there. That way you know that they're not together. So equals 2. So now we want to get rid of that number in the front by dividing both sides by 3. So log base 8 of 2x plus 7 equals 2/3. So now that the log and the argument are isolated, now I can convert it to exponential form. So my base is 8, and then my argument and my exponent switch. So the exponent is 2/3, and the argument is 2x plus 7. So again, this one you can just figure out by rewriting it in the other form, or you can just come over here to your calculator and say what is 8 to the 2/3. So we get that that's just 4. So 4 equals 2x plus 7. And then you just finish solving for x. So I'm not going to do all the intermediate steps because I'm going to run out of room. So I'm going to subtract 7. When I subtract 7, I get -3 equals 2x. So minus 7, 4 minus 7 is -3. Divided by 2, x is -3/2. So again, when you check, just check to make sure that this number is positive. If you did your steps correct, your answer should check out to be the right one. But even if you did it correctly, you still need to check that it's a positive. So here, let me erase all this side. And you can do this in your head. I don't need to see the work for checking, but you should always check. So we're going to do 2 times -3/2, and then plus 7. We get that it's 4. So I can go through the rest of it and I can double check that it works out. But as long as this thing is positive and I did my work correctly, it should be the right answer. But you should always check logs to make sure you get a positive number, because the domain has to be positive. Can't be negative or 0. Okay, so we have a few more. So I'm going to skip these because those are exponentials. I want to look at these because we solve them the same way, but you got to remember what the bases are. So here for this one, we're trying to get the log and the argument by itself. What's the argument? So this minus 7, since it's not in parentheses, it's not part of the log. So the log actually just ends right here. If it had parentheses, then it would be inside. Like this one has parentheses, so that one is part of the log. But this one is not. Okay, so I have to subtract or add first. So I'm going to add the 7 because it's outside the parentheses. And again, I'm going to separate these 3 times log. If there's no base, you have to remember that the base is 10. So always write the base there if it's not there. And then here, 7 plus 4 is 11. Okay, but it's still not isolated because we still got to get rid of that 3 in front. So we're going to divide or multiply by the 3. So divide both sides by 3. So I get log base 10 of x equals, if I try to divide this, I'm going to get an ugly decimal, and I don't want to round just yet, so I'm just going to leave it as 11 divided by 3. Because here, that's what it leaves it. I don't want to change it to a decimal just yet, not to the end. Okay, so from here, we want to take the log and turn it into an exponential. So the base of the exponential is going to be 10, and the other two just switch. So my exponent is now 11/3, and the argument is x. So really, x is whatever this decimal is here. So now at the very end, you can use the calculator and round. So 10 to the 11 divided by 3. And you can actually use this button for the 10, base 10, but I just type it in. Okay, so we get here 4,641 and 59. So we don't have to round this time because it's terminating decimal. We round to 3 decimal places if necessary. Okay, so over here, again, there's nothing on the outside. This minus 4 is part of the argument, so I leave it there. So I go straight into dividing by 3. And we get log. Go ahead and leave your base as 10. Go ahead and write the 10 there. X minus 4 equals, and over here we're going to get 2. So you need the 10 there in order to convert it, because the 10 wasn't there and you would use the wrong base when you write it as an exponential. So the base should be 10, and then you're going to square that and make it equal to x minus 4. So then 10 squared is 100, x minus 4. So if I finish solving within the grouping symbols, I just add 4. So x is 104. Okay, and again, check that it's positive. Here, when I plug this number in, I get 104 minus 4 is 100, so we're good. Here, this number is positive, and that's all that's inside. So then that one, since the answer is positive, the log's going to be positive, so we're good. Okay, so this is the common log. When there's no number there, you assume that it's 10. And then you also have to remember natural log. So the ln function here. So the first thing I'm going to do is write it in log form. So this part, actually I can go ahead and move the 6. So I'm going to subtract the 6 from the 15 and get 9. But instead of writing L in here, remember the natural log is log with a base of e. That's what natural log means. Okay, and the reason again you need that is so that when you convert it, so subtract or add first. A number in the front would be multiply or divide, but there is no number in the front, so we're going to skip that step. So we just go straight to changing a log to an exponential. So here the base of the exponential this time is e. The exponent is going to be 9. And the argument is 5x minus 1, or plus 1. So these we're definitely going to get a bunch of decimals. So we're going to do e to the 9th is that decimal right there. There's actually more to it, but I don't need the whole answer for this part. I'm just going to do 8103.08 ... because there's going to be more stuff. We just keep going. Oh, you know what? This one had more stuff too. I'll go back up and look at that one in just a second. But let's finish this one. So here, to finish solving for the rest of the grouping symbols, I subtract 1 from that. So I just take this answer and subtract 1. So then I get that decimal, which you can write out some of it if you want, but I just do ... just to know that it's stuff, other stuff is there, and then take that answer and divide it by 5. So x is okay, so I divided by 5 and I got this decimal, but if you need to, this is rounding it. If you need it to get the actual value, if you just highlight it and press enter, it'll give you the whole decimal, because here we want 3 decimal places. So we need, this one automatically rounds it to 2. So here we want to keep 3, so we're going to say, what is that, 16, 20, 0.1 or 4, 1, and that 7 is going to make this 6 a 7. Okay, so if your calculator automatically rounds to a certain decimal place, then you can just go up and highlight it to get more decimals. So for example, on example A, it was 59, but actually it was 5888, so that would have rounded it to 589, because the next one's an 8 as well. So it just depends on the answer choice or what the question is asking you. For us, we always want 3 decimal places here, so I didn't check A, but there goes A, and then here's C. Okay, so we're going to have to do that same thing for D. A lot of these have decimals, so you got to make sure you round to the correct decimal place. Okay, so for the last logarithmic equation, we're trying to get this part by itself. The 3 is not part of the argument, so I want to divide that away. Or sorry, subtract it away. So subtract the 3 from the 21. And we're going to get 4 times ln is log base e negative x equals 18. Then we can divide by that 4 in the front. So here you can divide, you can put it as a decimal, as a fraction. 18 divided by 4. Clear, I want to clear everything. So 18 divided by 4 it's going to reduce it, or you can make it a decimal however you want. 2, 1. I don't care how you write these answers, as long if it's terminating. If it keeps going, then make sure you leave it as fraction. But this one is terminating at 4.5. Okay, so then we get log base e of negative x equals 4.5. So now changing it to an exponential, the base is e, the exponent is 4.5, and it's equal to negative x. So that's a negative 1x, I'll put a little 1 there. Whatever answer we get, we're just going to divide it by negative 1. So here, we just go e to the 4.5. Oh, this gives me more decimals. Okay. So then we get 90.0171 equals negative 1x. And it's still not that answer. There's still more decimals. It's just rounding it to 4. Okay, so the last step would be just to divide by negative 1. All that's going to do to my answer is just make it negative. So divide it by negative 1. And if I want 3 decimals, x is negative 90.017, because the 1 is going to leave the 7 alone. See, and again, there was more to it. Besides, it didn't stop at 7 or 1. It's going to keep going with more stuff. We just round to 3. Okay, so that's solving logarithmic equations. Solving exponential is the same steps. You just go opposite way. You go from exponential to log instead of log to exponential. So that's what we're going to go back and do for the other ones.